for the planet, and that dates back to 1880. This was announced today by both NASA and NOAA, the Oceanic and Atmospheric Agency. 5 months last year set temperature records. The ocean surface was unusually warm around the world, except for Antarctica. In the U.S., the western part of the country baked under extreme heat, shown here in yellow, although the eastern half of the country saw below average temperatures, as you see here in blue. And there were temperature records set in several European countries. Well, we get further insight and information on all of this from one of the lead scientists involved with the report. Gavin Schmidt studies climate change at NASA's Goddard Institute for Space Studies. And Gavin Schmidt, we welcome you to the program.
Thank you very much for having me.
So fill this out a little bit more for us. How did 2014 differ from other years?
Well, 2014 was only a little bit different from previous years, but what we're seeing is a long-term trend that is producing record warm year after record warm year. The previous record was in 2010, before that 2005, before that 1998. So this year is part of a long-term trend that is just going to continue.
But when you say it's only a little different, I mean by a fraction of a fraction, is that right?
Right. I mean, so there is each year that makes a record. It's like people running a marathon. You know, they only beat the record by a few seconds each time. But times are getting faster. The globe is warming up.
And am I right? I believe I read today that the 10 hottest years on record have all occurred since 1997.
Yep, that's right. 9 of those have occurred in the last 10 years. 1998 was a real standout year, and so that's still in the top 5. But we've warmed about 1.5 degrees Fahrenheit since the beginning of the 20th century, and we can attribute those changes mainly to the increase in greenhouse gases, particularly carbon dioxide, that we've been putting into the atmosphere.
And just to be clear, I mean, we showed a map of the United States, the western part of the country very hot, but the eastern part cooler, but you still had overall this record. That's right.
I mean, in any one year, there is a lot of variability. You know, sometimes you have an El Nino event in the tropical Pacific that can make a difference. You always have weather and various natural variability that's going on. And so you never see a uniform pattern. You're always going to see some places that were warmer, some places that were cooler. But in our analysis, we're trying to average over all of those things to get a sense of what the whole globe is seeing on a long time scale.
So what do you and other scientists believe is going on here?
Well, so year to year, there's a lot of noise, there's a lot of chaos and dynamism in the climate system, but the underlying trend, the trends that we've seen since the 1970s particularly, that's being driven, that's being pushed, and it's being pushed mainly by carbon dioxide increases in the atmosphere, which are adding to the greenhouse effect, which is making the planet warmer.
Carbon dioxide meaning man-made emissions.
Yeah, carbon dioxide mainly comes from the burning of fossil fuels, coal, oil, natural gas, and from deforestation, mainly in the tropics.
So to the skeptics who are out there vocally when a report like this comes out saying, wait a minute, there's no proof that there's connection to what humans do, you say what?
So, you know, science works by putting all the bits of evidence together. We've looked for all sorts of different fingerprints of change. We've looked to see whether the warming is caused by oscillations in the ocean, or whether it's caused by changes in the sun or volcanoes or all sorts of different things. But what we find is that the picture that you get when you think about what's happening with greenhouse gases fits the data not just at the surface, but in but higher up in the atmosphere, in the ocean, in the Arctic, all around. And so we have a fingerprint of change that's associated with human activities, and that fingerprint fits the evidence that we're seeing in the data.
Separately, Gavin Schmidt, we saw yesterday in the journal Science this report that humans, it basically concludes, are causing unprecedented damage to the oceans and to life, to animals' life in the oceans. When you put that together with the temperature findings, what does that tell you?
Well, the human impact on the planet with the population that we have and the huge exponential growth in population, we're having exponentially growing effects on the planet across a whole suite of different metrics, whether it's ocean acidification, whether it's overfishing, whether it's habitat loss, whether it's deforestation. All of the graphs look very similar. It's flat for a long time and then it shoots up. We're in that exponential growth phase, and we have to be very, very careful that we don't exceed our reach and damage systems that can't be recovered. Any
glimmer of hopefulness in all this?
Well, I think the glimmer of hopefulness is that we're having a conversation about that. We're discussing these things, hopefully in a sustainable manner. We're talking about ways to mitigate and to adapt to the changes that we're coming about. And these kind of conversations that we're having now help raise awareness and help us make sure that the people who are making decisions in the full light of the scientific evidence that we have found.
Gavin Schmidt, who is the director of the Goddard Institute for Space Studies.